Game Theory Part 2. In this webcast we're going to illustrate how to solve a simultaneous move game. Consider first the example of an innovation race involving a shared R&D between two consumer electronic firms. So on one hand we have firm P and we have firm S. Each firm plans to develop an interactive CD technology and expect subsequent commercialization applications. Both firms can wait or invest, with according payoffs. The total market value from immediate investment, whether by a single firm or shared equally among the two firms, is 400 million. So if both firms invest simultaneously, over here and over here, they both share equally the 400 million and they receive 200 million, each of them. It can also be the case that one of the firm moves first and the other one doesn't invest or waits. In that case, the first mover captures the complete market. If firm P moves first and firm S waits, we're over here, and firm P receives the total value of 400 million and firm S receives 0. In the other case, firm S moves first and firm P waits, firm P receives 0 and firm S receives the whole market value. In the last scenario, both firms wait. And if both firms wait, they have the flexibility of option value, which increases the total market value from 400 to 600. In this case, they share equally the 600, and the value of waiting is 300 and 300. To solve this simultaneous move game, we apply Rule 1. This means that we look for dominant strategies, or strategy that always gives a higher payoff independent of the actions or strategies of a rival. Consider investing by firm P. If firm P invests, his payoff if firm S waits dominates waiting, because 400 is bigger than 300. But also in the case firm S invests, investing for firm P dominates waiting, because 200 is bigger than 100. So independent what firm S does, firm P has always a higher payoff when investing. This is a dominant strategy. Or in other words, Rule 2, the waiting strategy is dominated or can be eliminated. We can do a similar analysis for firm S. For firm S, investing dominates waiting, because 400 is larger than 300. And if firm P invests, 200 is larger than 0. So firm S always also has a dominant strategy to invest, independent of the strategy of firm P. The resulting Nash equilibrium are the two dominant strategies, and we end up here in the lower right cell. Both firms end up having 200 and 200. This Nash equilibrium is lower than in the cooperative equilibrium where both firms wait. It's 300, 300. The simultaneous move game is depicted in the normal form. And the normal form is the matrix form as you see here on the left hand side of this figure. Another way of expressing this game is the extensive form or tree-like form. In the extensive form, we see branches of each of the actions of the firms. So firm P can wait or invest, and firm S can also wait or invest. This dotted line in the middle means that they have the same information set or that the actions move simultaneously.